Hi everyone. So this is the third video of the Power Series lectures. Before we start, a brief review of what was done in the first two videos. In the first video, I introduced what's a Power Series, and I also introduced the ratio and root test in order to know when these series converge. In the second video, we've made a first example in which we have seen that the series converges only when x is equal to 0. Let's have a look now at this example. Okay, for which values of x is this series convergent? Okay, now you might want to remember that what is the factorial here? 2n factorial means 2n's times 2n minus 1 times 2n minus 2 times 2n minus 3 times, so it has a lot of factors, times 3 times 2 times 1, and then it ends there. Okay, so for n, when n is really, really large, so when n is approaching infinity, this will have it will have a very, very large amount of factors, like a number of factors that is also approaching infinity. So dividing successive terms here is something we want to do to cancel most of these factors out. So whenever you have a factorial like this, it gives away the ratio test. Okay, so we're going to use the ratio test. Remember that for the ratio test, what you do is the limit as n is approaching infinity of an plus 1 over an. And then, okay, so let's see where we need the absolute value and where we don't. And something you might want to remember here is to actually write it like this. So it's going to be an plus 1, because this has a numerator and a denominator, right? So what you would like to do is to write it more as something like this. Why do I say this? It's just because it makes the display much easier, right? So an plus 1, what is that? So it's exactly this, but instead of n, you will write n plus 1. So let's just color code this in green. We have x to the power of n plus 1 divided by 2 times, and instead of n, you write n plus 1 factorial, like this. Okay, so this is your an plus 1. Now, an is exactly that, but what you have here is 1 over an. This means that you're gonna flip it. You're gonna write the reciprocal of it. So you're gonna write 2n factorial divided by x to the power of n. Now, for now, I don't mind the absolute values, but I already know that these two are positive numbers. We could take them out of the absolute values. And I also know, okay, let's first do this, all right? Let's first say it's going to be the limit as n is approaching infinity. So 2n factorial, we know it's positive. No issues here, okay? And we're going to divide this. Be careful here. You need to distribute by 2n plus 2 factorial. There you go. Yeah, you distribute this, and this is a factorial. Multiplied by the absolute value. Now this, you want to cancel with this, which means you're going to use the rules of exponents to express this as x to the power of n times x. The denominator is certainly going to be just x to the power of n. Okay. Next step. This and this cancels. We're very happy. Now we have to deal with the factorial. So here's how we do. I'm going to use a new line here. Limit as n is approaching infinity. Which one is bigger, this one or this one? Okay, it turns out that this is the bigger one. Like it starts at 2n plus 2, then 2n plus 1, then 2n, 2n minus 1, and this one's only start at 2n. Notice how we said that eventually this will hit 2n. So that's the idea. This one we don't change because it's the smallest one, but this one, the one at the bottom, okay? So we know it's going to be 2n plus 2 multiplied by 2n plus 1, multiplied by 2n, 2n minus 1. So multiplied by 2n factorial. So whenever we stop writing, we have to put a factorial because, yes, it still contains the factor all the way down to 1. Okay? Now, this over this, we know we're going to have the absolute value of x. And now, as you can see, you achieve the purpose. So this and this cancels. So the final limit, you have the limit as n is approaching infinity of absolute value of x divided by 2n plus 2 to n plus 1. Now, x is a fixed number, right? Remember, it's the variable that you replace. You replace x, let's say, by 1 million, and you would like to know if it's convergent or divergent. Well, here you have your answer, right? Because x can be as big as it wants. You don't care, but it's going to be fixed, right? It's going to have like a fixed value, whereas n is growing to infinity. So x can be as big as it wants. Eventually, it will be overgrown by the denominator. So let's actually write that down. So regardless of x in real, okay? So 2n plus 2 times 2n plus 1 will eventually overgrow the absolute value of x. And this means that this limit, regardless of x, is equal to 0. This is smaller than 1, and therefore this series converges for any single value of x. Okay, so this series converges for every value of x. And you might want to add here that this is by the case 1 of the ratio test. Case 1 of ratio test. Hopefully this is clear. Next video, we see another example that is again fundamentally different than the first two that we have seen. See you there.